So this will be our presentation. It's by Team Segmentation Fault and Team This is the Best Name. Firstly, we would like to do some self-introduction. My name is Chang Jun, and these are two of my teammates.
I'm Josiah Huang.
I'm Hayden Howe.
From Team This is the Best Name, I am Ho Han Wing, as seen in the right side of the picture.
I'm 𝐿𝐿𝐿.
And I'm Raphael Lim.
All of us have had prior C++ experience and have taken part in RCAP CoSpace before.
Okay, so in terms of the summary of the challenge, I'm going to be quick with this. In case anyone doesn't really know the CoSpace rescue, our task is to collect the red, cyan, black, super, and super plus object. Okay, then after that, we will need to deposit the objects into the deposit area. There's also a lot of obstacles, traps, which we will need to avoid, and also make sure our robots stay in the border. In the map, there's also a double point zone, which basically double your point. And also, there's also swarm area, which slows down your robot. And lastly, is the information loss area, which you will lose your code. Okay, then last one is I'll skip through. So this will be our main presentation. First, we were talking about how we pick up the object. Then how we navigate around the map. And lastly is how do we target the map.
So now we'll be discussing the optimal combination of objects. So red objects are worth 10 points, cyan points are cyan objects are worth 15 points, and black objects are worth 20 points. The objects are found around the map. Super objects are worth 90 points, and these are objects which are made by a set of objects. One red, one cyan, one black deposited. Super plus objects worth 180 points are made by two sets of objects, two red, two cyan, and two black objects. Super objects' coordinates will be given, making it possible to pathfind to these objects. So this is a graph showing the scores for each combination, including super and super plus objects. In the case of you pick up all black, you will get 720 points. If you pick up 4 blacks, 1 red, and 1 cyan, you will get 1,170 points. Whereas if you pick up 2 red, 2 cyan, and 2 black objects, you will get 1,620 points.
Now I would like to touch on how to pick up super and normal objects. First and foremost, the ordering of objects picked up should be optimal to minimize the time wasted. To spawn as many super plus objects as possible, we should get as many pairs of RR, BB, and CC. Once the number of super plus objects picked up is sufficient, we can go deposit them when when the board is fully loaded with objects. As for avoiding obstacles, border, swarm area, and traps, the color sensor is used for both traps and swarm areas. When they are detected, we'll turn away from the trap and swarm area. Coordinates are used to avoid borders. When the board's coordinate is 0, 360, or 270, we'll turn away. Lastly, ultrasonic sensors are used to avoid the walls, and the steering is inversely proportional to the ultrasonic sensor.
Since coordinates of the super object is given and deposit zones are known, pathfinding can be used to find the shortest path from the robot to any location. But the question is, what pathfinding algorithm should we use? There's breadth first search with a time complexity of O of V plus E, A star with O of V plus E log V, Dijkstra's algorithm with the time complexity of O of V plus E log V, and Bellman fault with O of V E, where V is the number of vertices and E is the number of edges. We decided on A star as it uses a heuristic and will be faster in most cases, even though it does not have a faster time complexity. As in, the A102 function can be used to find the appropriate angle for the robot to face. We use the built-in turn to function provided by the simulator to turn towards an angle and go to the spot.
Throughout our experience in CoSpace Rescue, there are many different skills and concepts which can apply to the real world. For example, pathfinding. We can use pathfinding in order to find the shortest path from one node to another. In applications such as Google Maps, this will be extremely important. This can also be applied to real robots to allow us to find the shortest distance between two paths. We can also use odometry, which was used when we encountered a position info loss zone in CoSpace Rescue, to extrapolate the robot's future position in order for us to plan our path better. Next, in CoSpace Rescue, we had to choose the best possible combination of objects in order to increase efficiency, allowing us to gain more points. In real-life scenarios, this teaches us good time efficiency, allowing us to better spend our time more importantly. Finally, obstacle avoidance. A good obstacle avoidance in real-life scenarios can be translated into that Tesla uses. For example, it allows it to detect nearby obstacles, allowing it to avoid them easily.
All these strategies drastically improve the robot's performance with fast deposit times, fast super object collection, smooth obstacle avoidance, and efficiency in general. What can be improved is the picking up of normal objects and obstacle and swarm avoidance. Through this, we learn how to implement the 𝐴* search algorithm, trigonometry application, OpenCV, and debugging.
Now I'm going to share a quote. No matter how much falls on us, we keep plowing ahead. That's the only way to keep the roads clear. This really summarizes our experience, and it's the epitome of our learning. Thank you for your attention.